So we're continuing talking about solving exponential equations. I'm just throwing in a little bit of extra. We say, what happens if one of our numbers is a fraction? And it might seem like, oh, it's impossible, and it wasn't as obvious when I asked the kids yesterday, but it's really not that big of a change. It's just going to add one step to our process. So if we consider 1 over 64 to be to the first power, right? And then if we remember our rules for exponents when we deal with fractions, which was we can take any fraction, right? We can take the reciprocal of that fraction, and it keeps the same value if we take the opposite power. So I can rewrite 1 over 64 as 64 over 1, or just 64, and then I'm going to say that's to the negative first power. And just like that, now the fraction is gone. So all I did was I took my original value, right? And then I took the opposite sign. Okay? On the other side, nothing changed here. So this is 16 to the 3x. So now I look, I've got 16, I've got 64. What do they have in common? Well, I know 16 is 4 times 4, and 64 is 4 to the third. So let me write it out like that. So I'm going to say 4 squared to the 3x power, and then this is 4 to the third power, still raised to the negative first. Okay, then I simplify. So 2 times 3x is going to give me 4 to the 6x power. Over here, 3 times negative 1 is the negative third power. Okay, and then once I have my base is the same, I'm going to look at my two exponents and I'm going to set them equal to each other. So 6x equals negative 3, and then I get x by itself. So I divide both sides by 6, so I get x equals negative 3 over 6, or x just equals negative 1/2. Okay? So notice really the only change, the only difference from yesterday was we get rid of the fraction by just flipping it over and then taking the opposite of our power. Okay? So let's try another one. See what else we got. All right, so 4 to the 2x power equals 1 over 16 to the negative x power. Okay? So again, I want to get rid of this fraction. And how I like to write this out, you might not have to, but it helps me to see it, is I'm going to say this 1 over 16 is equal to 16 over 1 to the negative first power, and then I'm just going to raise that to the negative x power, right? And then when I multiply these together, I know that's just going to give me 16 to the positive x, right? Negative 1 times negative x is positive x, okay? So I just raise this to the negative first power just so I know I need to take the opposite of everything in my original exponent, and I like to show my work. Okay? This equals 4 to the 2x power. And then I look for a common base. So we could do 2, but 16 is just 4 times 4, so why not keep this simple? Let's say both of our bases are going to be 4. So this is going to be 4 squared raised to the x power. And then something interesting happens here. So this is 4 to the 2x equals, and then over here is 4 to the 2x. Well, now I have the exact same thing on my left and right. So these are equal no matter what x is. So we say the answer here is all real numbers. So if you simplify it, then you end up with the exact same number, right? Or if you want to see it, right? Because when we get to this last step, we take our two powers and we set them equal to each other. 2x equals 2x, and then if we want to get x by itself, we would subtract 2x from both sides, and we're left with 0 equals 0. And if your variables cancel out and you're left with a true statement, then the answer is all real numbers. That's how it is, right? As long as you've been solving equations, if the variables all go away, You have a true statement at the end. Answer is all real numbers. Okay? So there's another extra thing we're adding. So if this one is all real numbers, you can probably speculate as to how this is going to turn out. But let's try it. Let's see what happens. So 81 to the negative 3x powered equals 1/9 to the negative x minus 2. Okay. So again, I'm going to start with my fraction. And I'm going to rewrite this as 9 to the negative first to the negative x minus 2 power. So I'm going to multiply negative 1 times negative x minus 2. So that just flips all my signs around. So it's going to be positive x plus 2. Over here, 81 to the negative 3x. So 81 and 9, I'm looking for a common base. We could do 3, but 81 is just 9 times 9. And again, why work harder if we can work smarter? So I'm just going to say 9. 9 squared is 81 to the negative 3x equals 9 to the x plus 2. All right. So on the left-hand side, 2 times negative 3x is negative 6x. Over here, 9 equals x plus 2. Ah, we tricked you. This is not a no solution. This is just a regular problem. So we have negative 6x, we have x plus 2. We set those equal to each other. Negative 6x equals x plus 2. Let's bring the x over. I don't really like negative x's, but that's life sometimes. So negative 7x equals positive 2. Divide both sides by negative 7. And we're left with x equals negative 2 sevenths. So is that kind of an ugly answer? Yes. Is that a possible answer? Of course. And that's, that happens sometimes. Sometimes you get fractions because, we started with fractions. Okay? So that's it. So you say, oh, so how do I know if it's a no solution? I say, okay, calm down. So if we came back here, let's say we adjusted this problem. Let's say we ended up instead of, let's erase all this. Let's erase this too. So what if instead of 4, let's get rid of this. Oh, you're not distracted. So what if we had 4 to the 2x, and then over here we have 4 to the 2x plus 1. Right? So when I set it up, 2x equals 2x plus 1. So these will still cancel out, all our x's. So we have 0 equals, but on the other side we have 1. So if the variables cancel out, and you're left with an incorrect statement, 0 does not equal 1. That's not true, which means there's no value of x that will make this statement true. So this is our case where there is no solution. So the variables need to cancel out, and you need to be left with one number that does not equal the number on the other side. Okay? You will see at least one of each kind of question, no solution and all real numbers. So be careful, take your time, have fun with it, and we'll see you tomorrow. Bye.